All right, section 3 is going to talk about polar coordinates. So trigonometry is still going to be involved, but maybe not in the same way as what we've been used to. So what I am actually going to do is Google the unit circle. So then that way I can reference it when we need it. So if you have your unit circle, take it out. Otherwise, have a unit circle handy like me. So hopefully by now, most of you know that the point 3, -2 is indicative of a point on the coordinate plane. The first number tells you how many units to move right or left, and the second number tells you how many units to go up or down. So positive numbers are right or up, negative numbers are left or down. This is true on the Cartesian coordinate plane created by René Descartes, also known as rectangular coordinates. You're probably thinking, duh, Miss Barrett, but what do mathematicians do when they're bored or quarantined? They create new coordinate planes. So there's something called the polar coordinate system that looks like a regular point, but is defined differently. So instead of the first number being the x coordinate and the second number being the y coordinate, the first number is a directed distance from the pole, which just means the center. And when we look down here, the pole would be the center of this graph. So the first point is a distance, and then the second coordinate is theta, which is an angle, and it's going to tell you how many degrees or radians to rotate. So whether you're rotating up or down. So I think the best way to explain this is to show you an example. So plotting the point 3 comma pi over 4. So a polar coordinate system looks like this. It has these angles on there. It's got these circles. So the first coordinate is 3, and that's r. So that means I am going to extend to the right 3 units. So I am going to go out 1, 2, 3. So that's not where the point is because theta is pi over 4. So they want you to extend 3 units out, and then they want you to rotate positive pi over 4 degrees. So I'll let the red point be the answer. Out 3 units, rotate pi over 4. So point P would be located right there. So I go out 3 units, and then I rotate pi over 4 radians. So if I look at point A here and I say I'm going to plot point A, so that means I want to go out 2 units and then I want to rotate 135 degrees. So obviously this polar coordinate system is in radians. If you need to reference your unit circle as far as where 135 degrees is, you can do that. Oh, I guess I can't. Right, there I go. So 135 degrees is right there. So I'm going to go out 2 units, and then I'm going to rotate 135 degrees, which is equivalent to 3 pi over 4. So on the second ring, I'm going to construct the point on 135 degrees, and that is where point A is. So how do negatives affect this? Well, if r, the first coordinate, is a -3, then instead of going out to the right, I'm going to go out to the left. So I want to go to the left 3 units. So I'm going to go 1, 2, 3, out 3 units. And then from there, I'm going to rotate 3 pi over 2. So 3 pi over 2 from the positive axis is, I don't know how I did that, is 3/4 of the way around the circle. So maybe I can't, whatever. There we go. So 3/4 of the way around the circle from the positive axis looks like that. I want to start, though, at the negative part, and I want to rotate 3/4 of the circle. So I'm actually going to end up top. So from this point 3 units in the negative direction, I want to rotate 3/4 of the way around the circle. I want to rotate 3 pi over 2 radians. So point B is up here. It is not down at the bottom because I started off going negative. So you have to keep that in mind. The theta is from where you start. So if you start negative, you're going to rotate from that negative point. And then C has got a negative theta. So how does that affect it? Well, R is +1. So let me clean up some of my extra here. R is +1, which means I'm going to go out to the right 1 unit. And then they want me to rotate -pi/4 radians. And so theta being positive or negative, positive angles are counterclockwise and negative angles are clockwise. So I am going to rotate from 1, I'm going to rotate -pi/4, which would end up right here. -pi/4 is the same thing as at the same location as 7pi/4. So this point here would be C. And just while we're talking, sometimes they'll draw a ray. They'll have a ray extending from the pole through the point, and they'll have maybe an angle measured or something like that. Those extra details, the My Math Lab assignment might show you, but it's just extra features to get you there. So letter D is a -4 and a -90 degrees. So the first thing I'm going to do is R is go out to the left 4 units. So I'm going to go out 1, 2, 3, 4. So I know I'm on the 4th ring. And then they want me to rotate -90 degrees. So let me think about what it means to go -90 degrees. It means clockwise. So from here, which way does a clock go? From this point, the clock's going to go like this. So I want to go -90 degrees, which is actually going to end up right here on the same level as B, just on the same angle as B, just at a different layer. So this point D is up here. So I go out 4 units to the left, and then I backtrack 90 degrees or pi/2 or -90 degrees. Okay, so that is the basics of plotting points.